All right. So today's session is, as I said before, today's session is going to be on some other advanced hooks that are typically used in React. So some of those hooks involve useReducer and useContext. These are two tools that will become really useful as our applications grow in complexity, and both solve problems that you would naturally run into on real projects. And now let's take a look at today's agenda. So this is the kind of the agenda we have for today's session. And so we're just going to be starting with the problems with useState, and then we will take a closer look into the useState and the useReducer hooks, and then we will take a closer look at as to what kind of problems they would solve, and then and then after that, we'll just move into global state and sharing, where we talk about prop drilling and how use context solves it by making shared data across the nodes in the DOM tree. And then we'll just wrap up with some key takeaways and what comes next. So let's begin with the first challenge. What happens when your use state hooks start to multiply? So the challenge, so while use state really one of the is really one of the excuse me. So when use state is one of the hooks that are commonly used, this turns out to be a problem once the component starts to get a little more complex. You would usually start with one or maybe two use state hooks, but over time that can grow into several related pieces of state which could be tied to the same feature. And the issue with that is is typically known as hook proliferation. In something, so let's consider a login form. We may have so if we were to build a login form in React, we may have separate state for email, password, loading, and errors, and all of those values are related. And another problem with the use state is scattered logic. The state itself is not the main problem. The real problem is that the update logic gets spread across different handlers and different parts of the component, which in turn makes the code harder to maintain. And then another issue with using too many use state hooks is traceability. So when one user action needs to update multiple values at once, it becomes harder to track what changed and why. So the pain point with multiple use state hooks is not just having more state, it's just that the logic for changing that state becomes a bit more fragmented. And then in this login form example, the form is still manageable, but you can already start to see the pattern. There will be we have separate setters for each fields plus loading and error state. And then inside the handler for the submit button, we already need multiple updates together, like setting, loading, and clearing errors before the login logic even runs. So this is fine for the login statement, but login form. But imagine a much more complex form, like when we want to register a user and get multiple fields like their name, the address. So as forms get bigger, this approach becomes a much harder to scale and maintain. And this is exactly the kind of problem the reducer pattern is designed to solve. Okay, so instead of just updating the state directly, you what can actually be done is that you could dispatch a message and so this is where the mindset changes. So instead of thinking that I want to update this piece of state directly, we start thinking that, right, an action has happened and I want to describe that action clearly. So this is what we're doing with the reducer pattern. So in this pattern, we dispatch a message which is simply an action, and that action is just a plain object with the type field, and if needed, a payload that contains extra data. So the idea is the core of the Redux style pattern, which is commonly used in useReducer. So a simpler the way to think about this is that dispatch is kind of like the messenger, while its only job is to just deliver the requests. The action is the request itself. It's a standardized description of what has happened. And the reducer is the rule book, is kind of like this manager that decides how that order should be processed based on the rules that has determined. And then let's take a look at the example on the right. So if you want to just update a form field, we would dispatch an action, probably something to the effect of set field, which would include the field change plus the new value in the payload. And if the login fails, we could just dispatch something like login error with the error message. Uh, you can yes. I see that I have a hand raised already. Yes, Taji.
What would you say is the difference between useState and dispatch?
The difference between okay, so that's actually a good question. Use state and dispatch are both ways to trigger state updates, but they work at different levels. So with use state, you would usually update state variables directly, like by calling this setter, or you would usually update the reference, like using the spread operator and updating it by one. So with use state, you are telling React what the next value should be. But when it comes to dispatch, you're not directly setting the value. Instead, you are sending an object, and then the reducer decides how states should change based on that action. So use state is direct and simple, while dispatch is indirect but more structured. But that structure becomes useful when the state is more complex. For example, when we want to change multiple values together, or when you want all update logic in one place.
Interesting. So dispatch is more indirect, but easier to use when the coding is more complex, while useState is useful for when it's simple.
Yes.
Okay.
Right, and that distinction is exactly why reducer-based state management has more scales better for more complicated components. Now, let's take a look at the reducer logic that I have been talking about. It's just so what is a reducer? It's nothing but a pure function that's written in JavaScript, so which means that it takes the current state and an action, and it just returns the next state. And then and then when it comes to functions like this, they typically should not cause side effects. And for the same input, it should always produce the same output. So the key idea is that the functions like these, they just take the current state and the action, and based on our logic, it returns a new state. And then the second is like the the transitions for such reducer states are predictable. So if the same state and same action go in, the same result would come out every single time. And the third is immutability. One of the most crucial rules in React is that we never mutate state directly. We always return a brand new object. And then on the right side, we can see a simple example of a reducer function that is used to toggle between that could be used to toggle between dark mode and light mode, and that actions could also be used to set the font size. So it returns a new font object with the updated font size from the payload. And then such reducer functions has a default case, because typically the kind of actions for multiple actions we could use a switch case, but in this case the default case just returns the existing state that is unchanged if the action type remains unknown. And then always notice to the use of the spread operator here. That's exactly what preserves the rest of the existing state while updating just one field. So a reducer gives us one centralized predictable place for all state transitions. And then now that we've taken a look at what a reducer is, the next question, okay, what would be an example of breaking an immutability rule? Uh, okay, so an example would be modifying the existing state object or array directly instead of instead of returning a new one. So let's consider this example right here. So instead of using the spread operator, if I used something like state state dot let's say if we are trying to count there's a variable called state, and if we are trying to directly update it by just either directly updating this value by just one. So this is one example that would break immutability. And another example of the immutability would be, let's say that there is a state variable called items, which has your current shopping items list. And if we wanted to update the cart by adding new items, and instead of updating it using the spread operator, we would use the push method to add the new item. So this is one example of these are two examples where the immutability rule gets broken, because React always considers the references and not the values itself. So I hope that answered your question. Okay, how do I remove this? Okay. Okay, now let's come back to the comparisons slide. Okay, so now that we've seen what a reducer is, the next question that probably is in your mind is when should we use state and when should we use reducer. So use state is usually a better fit for simple isolated values like a string or a boolean or a number. Use reducer is more useful when the state is more complex, especially when you're managing objects, arrays, or several related values that often change together. And then the mental model is different as well. So with useState, you simply set the new state value itself. But with useReducer, you dispatch an action describing what happened, and the reducer computes the next state based on the action and the payload that has been set. And then the logic, the location, location of the logic also changes. With useState, update logic often lives inside event handlers in the component, while with useReducer, that logic is centralized in one reducer function, which makes the flow easier to reason about, and that affects testability. So when we want to test components that have use state, testing often happens through the component itself. But with reuse reducer, since the reducer is a pure function, state transitions are easier to test independently. So the main benefits of use reducers are that it centralizes the complex state logic and separates the update logic from the component itself, which usually makes components cleaner and more predictable. But one trade-off of that is that it would add more boilerplate code. So for very simple cases, it can feel a bit unnecessary. So use reducer does not replace use state. It's just a better option for when the state logic becomes more structured or more complex. Now that we have compared those two, let's move into another problem, another scaling problem in React, which is sharing state across components without passing props through every single level. No. So before we do that, let's see what useReducer actually looks like in a component. The implementation usually happens in three simple steps. The step one is initialization. We call use reducer and pass in two things. The two things are user reducer function and the initial state. The step two is the hook output. So use reducer gives us back the current state and a dispatch function. So this is similar to use state, but instead of getting a setter function, we get the dispatch function. And then the third step is triggering actions. Inside event handlers, instead of calling several state setters, we call dispatch with an action object, and that action describes what happens, and the reducer decides how to update that state. So, in this example on the right here, the initial state contains the email password is loading and the error variables as well. And then we define the login reducer, which would contain the logic for how those values change for different actions. And then inside the login form, we would just use the use reducer hook, and then and then pass on the login reducer and the initial state. And once we get the output inside the event handler, we would after preventing the form default form behavior, we would dispatch the output state that has been given from the use reducer right here. And uh, and that would give us one clear event that the useReducer can respond to, instead of scattering multiple set state calls across the component. So the big advantage here is that the component describes events while the reducer owns the state transition logic. And now that we've seen use reducer in practice, let's take a closer look at the next scaling issue, which is sharing a state across components. So now, this problem is often even known as prop drilling. And then prop drilling means that sometimes props have to be passed down through many layers of nested components. The issue is that intermediate components often don't need the props themselves. They're only just acting as conduits, just forwarding the values downward, which makes the component tree harder to maintain. because components only become coupled to data that they do not actually use. And another way to think about it is it's like passing a package from the first floor to the 10th floor by hand. But the only problem is it that package is stopping at every single floor, even though the person on the 10th floor actually needs it. And then in this example on the right, the our app component creates a user project object and passes it on to the home page. And then homepage, while the homepage does not require the user, it just passes it down again to the header that may actually use it. And then header is the component that finally uses it to render the welcome message. So the problem with that is not that the data is wrong. The problem is that components in the middle are forced to know about and pass props that they do not that would not they wouldn't typically care about. And that is the exact kind of problem use context is designed to solve. So with use context, it gives us a way to share values between components without explicitly passing props through every level of the tree. So in other words, instead of manually forwarding data through intermediate components, we can make that data available to any descendants that needs it. And there are three steps to implement this. The step one is just to create that context using React.create context, which would give us a context objects that React can use to hold shared data. The next step is to provide that context. We would wrap the component tree with the provider and actually and pass a value prop. So that value becomes available to components inside the subtree. The last step would be to consume the context itself. And then any child component that's inside that provider can call context method and access the shared value directly. So in this diagram, let's consider the example from before, where app provides the user value at a higher level, and that would mean that descendants like header and content or anyone further down the tree can access it when needed, instead of passing it through the homepage and many middlemen that would be responsible if it was not wrapped in the appropriate context. And then in this code example on the right, this is how you would typically go about create about implementing the context. We would first create the user context, and then in the app we would wrap the homepage with the user context provider, and that's where we would pass the user value that has been passed from the app component itself. And then finally, inside the header, we would just call the use context function, which would read the user directly without passing the same data through intermediate components. But one thing to keep in mind is that components using a context will re-render whenever the provider value changes. So if the value is a complex object, it is often a good idea to to memorize it. As for example, with use memo to avoid unnecessary updates. So use context solves the data sharing problem cleanly, but like any tool, it works best when it is used thoughtfully. And And now that we've taken a closer look, a look at all these hooks, let's try to understand. Let's try and remember what hooks can be used for different use cases in a React application. So useState is still the default choice when it comes to simple independent component states. And then when the state becomes more complex, especially when you have related variables or more structured transitions, use reducer is usually the better fit. And then when you need to share data like themes or user information across many components, use context helps you avoid the prop drilling problem that we had discussed in the earlier slides. And then a very powerful part, and then some of the powerful patterns that could be used to in bigger applications is preparing use reducer with use context, just to manage. That gives you a way to manage more global variables without bringing in any third party libraries. And then and looking ahead, once we start to dealing with server state like fetching and caching, that is where tools like React Query become more appropriate. So the big takeaway from this is that use reducer and use context are both really about managing complexity. One is for state logic and for one is for state sharing. When it comes to choosing between those two, they neither would be the is always the right tool. Use state and props are still the best choice for simpler scenarios. And then for the next session, we could and then for the next session we could try to take apply these same ideas to real API data where async state management with use reduce becomes more especially useful. So I guess we are at the end of the presentation. I'll just pause here and take some moments to answer any questions you guys may have. That's totally understandable. If that's completely normal with topics like this, and the good thing is that advanced hooks like these usually make more sense once you see them in code. So no worries if you don't have any questions. I will of course post the recording and you can go through it and hopefully and if you still have any questions, you can still DM me on Slack. uh, so if there are no questions, the uh, let's move to the walk through the coding examples that I have prepared for this session. And let me just take a few moments to share my screen. Okay, I hope that you all can see the screen. If not, just let me know in the chat. And now, this is so for our example, we are just building on the from the examples uh, from the last week's example itself. So for the app that so for the examples we had prepared in last week, we have just added a little bit of theme context because this is the clearest way to see your use context in action. So the first thing to notice is that uh, hmm. So the first thing to note that was the app was split into Okay, so the first thing, this would be the example for the theme context that we have seen, and this split actually is important because uh, first thing to the excuse me. Okay, so this was the theme context that allows us to switch between light and dark modes in the app itself. Because for a component to consume the theme context, it must be inside the theme provider itself. That's why we separate the provider setup from the component that actually reads the context. And then you can see at the top that the theme context is created with the create context method. The null is just the default value React would use if a component try to read the content outside a context outside a provider. And then use theme is a custom hook that simply wraps the use context function so that this keeps consumer components clear because they can easily just call the use theme hook itself. And then inside the theme provider, we store the current theme with the by just setting the state variable to light. And then the toggle theme function just flips from light and dark using the previous state value. And the this use memo right here is here to stabilize the value that is actually given by the provider. Without it, the theme variable object would be recreated on every render, which would make all the context consumers re-render more often than necessary. So that is why it's important to memorize this value. It's often a good pattern when objects are provided through context, and then the theme context provider wraps children, which is what makes the theme available throughout that subtree. Now let's switch over to the app itself and let's take a look at where the theme provider wraps the app because that's what allows the app content to consume this context safely. And okay. And now in app context, in this component, we can see why this separation exists. So app content is actually the component that consumes the theme context because it uses the theme use theme hook from the theme context itself, and it gets back and it gets back the object which stores me and a theme and the toggle function itself. And then right below that, we have also initialized the reducer function. We will be taking a look at that in a few minutes. So that this component is actually using two patterns side by side, but for different reasons. And then, of course, use context is also being used for sharing theme data. And then the reducer use reducer is being used for more structured local state transitions when it comes to selecting students. And then uh, let's take a look at our reducer itself. So for this for this reducer function, it will just it's just Okay, hold on, let me pause right here. I think I see a hand raised. Go ahead.
You just said the user reducer is being used in the students, right? Picking the students, right?
I'm sorry, could you repeat that? I couldn't hear you.
I said you said that the user reducer is playing a role in selecting the students.
Yes, it is selecting the student, and right now for this reducer function, all this is happening is just managing the logic for which student is currently selected. And then the point is not that selecting a student is that selecting a student is impossible with useState. You can still do that, and that's exactly what was done in the earlier examples. The only reason that we are using a reducer here is just to show how action-based state updates work, especially when you want all the selection rules in one predictable place. So, for example, this reducer already handles more than one rule. So, if the same student is clicked again, it deselects them. And there's also a dedicated deselect action and a clear action. So instead of scattering that logic across multiple handlers, we can centralize it in the reducer itself. So at the top, this state is just looking for the selected student, and then we define some action constraints like select, deselect, and just clear. Inside the reducer function, we switch on action type and return the next state that is based on the action.
Okay.
And now, okay, so for this, it's the code for there is not much changes in the app component itself, but let's take a closer look at our shopping list. So for the shopping list, what we can because this is one example. This is I think this would make things a bit more clearer for why use reducer helps. So here the reducer replaces several use state values from last week, and it manages them in a single in a centralized object. So at the top we have our imports, and then inside the shopping list you can see you can see that we are calling the reducer that has been imported itself, and then inside the shopping list we call that particular function and get back nothing but the state and dispatch. So from that reducer state we can pull out items, working items, which is the which is like the copy of the items that are currently in in our cart. And of course, this form dirty is just to suggest if there are any changes left to save, cancel, or just yeah. So, and then of course, let's take a look at the reducer together, and then and then you will see that this is one of the main benefits of the use reducer. So instead of spreading related update logic across many different handlers like we did last week, we put all the rules in one predictable function. So then at the top, the initial state has three pieces of state. One is is our initial card. The working items is just the temporary editable copy, and then is form dirty just tells us whether user has unseen changes. And then we have a an object for full of list actions. So these action names just describe the operations that are allowed in our shopping list. We could either add items, confirm, cancel, reset, and wrong. And there's another action called wrong addition. So inside the reducer, that we will definitely switch action type. The add item just returns a brand new state object. it keeps the old state with the spread operator, and it appends the new item to our editable copy, that is working items, and then it just sets the is form dirty to true. That means that the user is editing the temporary working copy. It's not the confirm list just yet. And then confirm just copies the editable copy, that is working items, onto items. So the temporary edits become the saved application state, and then cancel just throws away the temporary edits by resetting the working items back to our original card, that is items, and then reset would just take the whole reducer back to initial state. And then for the wrong addition item, this it is this action is included to demonstrate why the immutability rule must never be must not. It's just an example as to how the immutability rule can be broken. And so while so this is so when we try to directly make changes to the to our current card, that is where it would get updated by value itself. But instead of creating a new array, we are just changing the old array in place. So this is the problem is that React relies heavily on references to detect the changes. And so if you mutate the existing state directly, it may not detect the updates the way that you expect, which could lead to stale UI, inconsistent renders, or maybe just a huge headache whenever you want to debug them. So even though the code returns the state object, the array reference has already been mutated. So the damage is done before the return statement itself, which is why returning a new object alone is not enough if the nested data was mutated first. So the safer pattern is to always create a new array or object first. That would create the new value, as you can see in the above action items itself. So this reducer is a nice example of the right pattern, which includes the right pattern and the wrong pattern itself, which makes the immutability rule much easier to understand in practice. So now let's take a look at the at our application and see how everything looks in practice. Now, we're just taking a look at our app right now, and then what we can do is first we could switch to dark mode first, and then you can that so that is a context-driven picture because the theme value and the toggle function are being shared to the provider itself. And now just below that, let's just switch back to light mode. So this shopping list section is the example where we would be using the reducer hook. The key idea here is that the UI is no longer calling multiple state setters like we were in the initial example. So let's try to add some chicken to our list, and then you could see that it would either confirm or cancel. If we confirm, it stays in the list, and if we reset, the entire list has been reset to the 5 items. And then if we try to add chocolate using the wrong add action, so it will definitely be visible in the state itself. But if I try to add it here, so that's when it may not be visible at all. So even though the item appears in the confirmed list, even though this action is intentionally one way to show how those actions can be wrong. So it's because the reducer mutated the existing items array directly. So it changed the original state in place, instead of creating a new array. So by contrast, the normal add item flow updates the temporary copy first, and that is why when we then get the conform or cancel as proper when we try to add items using the proper workflow. So one path is following immutable state updates, and the other is deliberately showing what goes wrong when we mutate the existing state directly. You can also see that the conform list includes chocolate, which proves that the original application state was muted. So this example makes the reducer behavior very concrete. And now let's just scroll down to the student roster example where the reducer handles select, deselect, and clear while the theme still comes from context. So and now that we select, so right now if we try to select Ethan, and that is why the card uh, is being highlighted. And so this selected state is this time it's not being managed by separate booleans like we were doing in the previous example. It is being managed by the reducer function itself. So that which only keeps track of one selected student value and which gets updated through actions itself. So when I click a student, the app dispatches a select action. If that student was not selected before, the reducer just stores that student name as the current selection. And then if I select the same student again, the reducer can toggle it off by setting the selection back to null. And a clear action can reset the entire selection entirely. So at the same time, notice how this component can still read theme information directly from context. So that way we can get shared theme data without prop drilling and selection logic and structured selection logic without scattered handlers. Let's take a closer look at that, how it comes out to be. Uh, Right. So this is where it is just using the consuming the theme context directly. So as you can see, there's no theme prop needed from the app component itself. We can just so if we were to pass this property from the app component itself, we would have to pass them down to every level. So these are the examples that were just built on for today's session. Just I'll just pause here to see if there are any questions whatsoever about maybe this presentation or the examples that we just went through. Okay. Well, from the chat, it looks like you're okay. I hope that if you I hope that this session has been slightly has given you a bit more idea about the concepts we have discussed. It's okay if you don't have any questions. I will of course be posting this recording, and you can go through it as many times as you would like. And if you have any questions, you can definitely reach out to me on Slack, and I'll be sure to answer them as soon as possible. And I'll just stop the recording right here.